Hello, my name is Niamh Merriman and I'm a PhD student in the School of Psychology and Institute of Neuroscience in Trinity College, Dublin in Ireland. And I'm just here to present some of my findings from my PhD. My interest is in spatial cognition and how that changes as we get older, and also the factors that might disrupt spatial cognition or benefit it as we get older. So spatial cognition, why is it important? First of all, spatial cognition, in this sense, I'm referring to wayfinding, so how we find our way through our environments. And we do it every day, getting to work, getting home from work. Some of us do it well. If you're like me, you do it quite badly, especially in a new place. And also, when we find our way around, we tend to reference external cues, like landmarks, in order to find our way. And then without landmarks, spatial cognition is disrupted, like Suman et al. Found in this nice paper, where they threw a lot of people into a forest in Germany on a cloudy day without any landmarks, and turns out you do walk in circles when you've nothing to reference. So landmarks are important for finding our way. And so how do we navigate? So there are two different types of strategy or processes that we use in order to navigate. So egocentric spatial processing refers to the relationship between the self and an object. So for example, when I come to the post office, I associate that with a right turn to get to the restaurant. So it's the relationship between yourself and an object. And then allocentric processing, it's a more complex process, and it refers to the relationship between objects as opposed to the relationship between yourself and an object. So a landmark's location is defined by its relative direction to another landmark as opposed to yourself. And as you heard earlier, there are two different structures in the brain that subserve these different processes. So the caudate nucleus is involved in egocentric processing, kind of response strategy, it's called. So I come to the post office, I turn right. The hippocampus is more involved in allocentric processing, and it updates representations from our environment to create kind of a flexible mental map of our environment. So it's more complex in that way. And the environment itself can either lend itself to finding our way or to making this task harder. So the more complex the city, the more content within it, these things have an impact on navigation performance. And as we saw earlier, visual landmarks are very important for finding our way through the environment. So leads to the question, what happens in a changing environment? So for example, in a recession, some stores close and they're replaced by other stores. So what does that mean for how we find our way around? Are we using those as landmark cues to get around our environment? And what about our aging population? So according to the World Health Organization, by the year 2050, the number of older adults in our environment is going to really increase. And so we have to develop environments that encourage the active participation of older adults within society so they can keep their independence and be involved. So what happens to spatial cognition as we get older? So it becomes less efficient, and there is reduced activation in these areas in the brain responsible for these different types of strategy. So the allocentric processing and egocentric processing to a lesser extent. And then as we get older, as you heard earlier, we rely more on egocentric than allocentric processes and strategies to find our way around. So the relationship between yourself and a landmark. And also, older adults who feel themselves that they have a deficit in finding their way around the environment, they tend to avoid unfamiliar places and routes. But it's not all bad news. So as we get older, our memory for locations and environments learned in the distant past, that's preserved in older adults. And in some tasks, their performance is comparable to that of younger adults. There's also better spatial memory for familiar environments as we get older. And what's very interesting is that spatial memory can be improved with training, as Lofton and colleagues demonstrated in one of their papers. So there's good things too. And in this current study, so why is it relevant? So what happens to spatial navigation and wayfinding in familiar environments when novel landmarks are introduced? So does this disrupt how we find our way as we get older, or does the familiarity of the environment play a part? And so for this task, we used a virtual rendering of the Trinity College campus in Dublin. So it's a campus college, and it's very much divided into two ends. So we have the front end, that's quite iconic. It's home to the front gate and the Book of Kells, which some of you may have heard of, and it has a lot of footfall, a lot of tourists and traffic, and it's quite close to one of the main shopping areas. So, and we also have the back end of college, where buildings are newer, it's a bit more modern looking, and you really have no call to go down that end unless you study there or work there or a neuroscientist. And so here on the left, I have images from our virtual rendering of Trinity College, and these are actual pictures from Trinity College. And so even when you're looking on the web for pictures of Trinity, you'll get a lot of these from the front end of college, and very few from the back end. I had to take this picture myself just to have something to compare. And so with that in mind, in this task, we had two routes through Trinity College campus, one of this well-known area and one of this less well-known area. And so what happened was, our participants watched these videos, and while they watched, they were asked to try and remember as best they could the landmarks they encountered, what they were, where they were, what direction they went when they came to them. And after that, there were 5 tasks that they were asked to complete. So a landmark recognition task. So did this landmark match one that they saw on the route or not? A task looking at egocentric processing. So when you saw this landmark, did you go left, right, or straight past? Allocentric processing. So looking at the top landmark here, which of these 2 other landmarks were closer to it as the crow flies in the environment that the route went through? Landmark memory, they were given a map of the area that the route went through, and they had to name these landmarks. And landmark location memory, so they were given a blank map and they had to put X's everywhere they remembered encountering a landmark. So prior to the study, we obtained familiarity ratings from our participants for these 2 areas of the campus. And so we had 3 groups of participants. We had students who rated the front end as being equally familiar with the back end, because I suppose they're traversing the whole lot all the time. We had a group we called younger adults who weren't students and were only familiar with the front end of college. And then we had older adults who were also familiar with the front end and not the back end of college. And for the results. So for the landmark recognition, where they had to say yes or no as to whether they saw one of these landmarks on the route, we found that older adults performed less well than younger adults. And also, what's interesting is that performance was better for the well-known route versus the less well-known route for both younger and older adults. In these graphs, I'm just showing the results for the younger and older adults because the students performed equally well on both routes and their performance wasn't different from the younger adults. For egocentric processing, so which way did I go when I came to this landmark? Again, older adults were worse at this task, but again, there was a benefit for judging directions in the well-known versus the less well-known environment for both younger and older adults. So this is really quite interesting. We weren't expecting to see this kind of difference. And for the allocentric processing, it's a much harder task. Again, the older adults performed worse than the younger adults. There was no benefit or difference because of the familiarity of the area in this one. For the landmark recognition, again, the older adults were a bit worse at this than the younger adults. And again, it's quite close here, but no benefit statistically for the different environments. And for the landmark location memory task, where they had to put an X everywhere they remembered encountering a landmark, again, older adults did a bit worse on this task, but they did better for the well-known route than the less well-known route. Okay, so in general, the older adults performed worse at these tasks than the younger adults. But the familiarity of the environment seemed to preserve the spatial cognition of the older adults for a number of tasks. So the landmark recognition, the egocentric processing, and the landmark location. And so what does this mean for neuroscience and architecture? Well, novel environments, or novel landmarks in a familiar environment seem to benefit spatial cognition in older adults. And there's also a benefit for the younger adults, but their performance was also quite, it was really good and better than the older adults in general. But it does have implications for future studies and maintaining efficient spatial navigation skills as we get older. So results like these could inform interventions using virtual reality or augmented reality to present a subject with their own environment and maybe a broader environment, and encourage them to explore a bit more if they curtail their wayfinding because they feel they'll get lost. It might improve their confidence to do this and result in more active participation. And yeah, so I just like to say thank you, and these are my fellow collaborators here: Jan Ondřei, Eugenia Roudaia, Carol O'Sullivan, and Fiona Newell.